In section 4, we talked about ellipses. So we have ellipses centered at the origin, whose major axis is the x-axis, which is x squared over a squared plus y squared over b squared equals 1. And then whose major axis is the y-axis, which is x squared over b squared plus y squared over a squared equals 1. And then we had ellipses not centered at the origin. So the only thing that changes is that in the major axis, the numerator is now x minus h squared and y minus k squared. And for the major axis being the y-axis, you just switch where a squared and b squared are. So your center is at hk. A is the distance from your center to your vertices. B is the distance from your center to your co-vertices. And A is always greater than B. So we want to write that down. A is always greater than B. And then C is the distance from your center to your foci. And we use the equation B squared equals A squared minus C squared to find our foci. So in our first example, we have x squared over 100 plus y squared over 36 equals 1. And we want to find our center, vertices, co-vertices, and our foci. So I'm going to start with my center, which is going to be at 0, 0, since I'm not adding or subtracting anything from x or y in my numerator. For my vertices, whichever denominator is bigger is where a squared is. So in this case, a squared is 100, which means a is 10. And because it's with x, that tells me that my major axis is my x-axis, which means I add and subtract 10 from the x value of my vertex, which gives me 10, 0, and negative 10, 0. For my co-vertices, that tells me that 36 is b squared. So it tells me b is 6, and it's going to get added and subtracted from the y value of my center, so 0, 6, and 0, negative 6. And lastly, the foci. So now I need to solve for c. So I'm going to use the formula b squared, so 36 equals c squared minus a squared, a squared minus c squared, so 100 minus c squared. So we're going to subtract 100 from both sides. We'll get negative 64 equals negative c squared. Divide both sides by negative 1. C squared equals 64. Take the square root, and c is 8. And our foci are always along our major axis. So that means they're going to add and subtract from my x-coordinate. So my foci are going to be at 8, 0, and negative 8, 0. Our second example, we're given our equation. We want to identify our center, vertices, co-vertices, and foci. And then we're going to sketch our graph. So x plus 3 squared over 49 plus y minus 5 squared over 64 equals 1. So for the center, I'm going to do the opposite of what's with x and y, so negative 3, positive 5. For my vertices, a squared is going to be 64, which means a is 8. And because it's with my y value, my major axis is my y-axis, which means I'm going to add and subtract that to the y value of my vertex. So it's going to be negative 3, 13, and then negative 3, negative 3. For the co-vertices, b is going to be 7, which we are going to add and subtract from the x value of our center. So negative 3 minus 7 is going to be negative 10, 5. Negative 3 plus 7 is going to be 4, 5. And then for our foci, we'll use that b squared, 36, equals a squared, 64, minus c squared. Subtract 64 from both sides. We get negative 28 equals negative c squared. Divide by negative 1. C squared equals 28. Take the square root, and we get that c is approximately 5.3, which we're going to add and subtract from our y coordinate. So negative 3, comma 10.3 when we add, and then negative 3, 0.3 when we subtract. Now I can graph the ellipse. So I start with my center at negative 3, 5. I don't have enough room to graph the point negative 3, 13, but it's somewhere up there. Then negative 3 for our second vertice. Then negative 10, 5 for our covertice, and 4, 5 for our other covertice. And then we can do a rough sketch of our ellipse, which looks somewhat like a circle. Since A and B are 8 and 7, it looks very, very close to a circle. Last example, we want to write the equation of ellipse with a center at negative 4, negative 1, a vertex at negative 9, negative 1, and a foci at 6, negative 1. So the first thing I need to do is figure out which axis is my major axis. So I'm going to plot those 3 points to help me get an idea. So negative 4, negative 1 is somewhere around there. Negative 9, negative 1 for our vertex over here. And negative 6, negative 1 for our foci somewhere around here. I don't need to know exact points. I can just do a rough guess at this point. So because my vertex is to the left of my center, it tells me that my major axis is my x-axis, which means I'm going to be using the equation x minus h squared over a squared plus y minus k squared over b squared equals 1. We know A, so the distance from my center to my vertex is going to be 5. We know B, the distance from our center to our foci is 2. C is 2. Now we just need to find B. So we use the fact that b squared equals a squared, which is 25. So 5 squared minus c squared, so 2 squared. So we'll get 25 minus 4, which means b squared is 21. And again, I don't need to solve for b here because the equation for an ellipse uses b squared. So we'll have x plus 4 squared over 21 plus y plus 1 squared. Sorry, a should be in the denominator here. That should be 25. And then b squared, which is 21, equals 1. So again, opposite of what's with x, opposite of what's with y when you're putting it in, plugging in your vertex, and then a squared and b squared. And a squared is always going to be bigger than b squared.